Hello my students, your physics teacher Hassan Darwish with you. Again we continue the explanation of chapter 4 about radioactivity. In the last video we explained finally the alpha decay, right? Now we start with beta minus decay or beta minus radiation. Now what is beta minus radiation or beta minus decay? First, beta minus particle, as we said at the beginning of the chapter, is nothing more than what? Electron. It is released with very high speed from the nucleus, which is close to the speed of light. Now the reaction is simply, we have the parent nucleus here with A and Z, transform or disintegrate or transmute into the daughter nucleus with A prime, Z prime, plus the beta minus particle, which is what? Electron. Okay? Now if this daughter nucleus is created or produced in an excited state, then it emits what? Gamma. So you add here what? Plus gamma. But he has to mention this in the exercise. I don't know if the daughter nucleus is created in an excited level or not. Okay? So you know, conservation of mass number and atomic number, or Soddy's laws. A equal A prime plus 0 means A equal A prime. Z equal Z prime minus 1 here means Z prime equal Z equals Z prime minus 1. Z equals Z prime minus 1. Right? Let me give you an example. Here we have carbon isotope, mass number 14 and atomic number 6. This carbon isotope is unstable in nucleus. It disintegrates, means transform, into more stable one, which is nitrogen, with 14,7 plus the electron. Notice here, this is 0, 14, 14. Now look here, minus 1 plus 7 equals 6. So this is what? 6. So mass number and atomic number are conserved. Right? Any problem? Let's go now to the final particle, beta plus. Now beta plus decay or radiation. Beta plus, as I said, is a new particle for you. It's called what? Positron. Positron means from positive, tron from electron, because it very looks like the electron. That's why it's called the antiparticle of electron. It's the same as electron, but its charge is positive. So it's completely different from the proton. Okay? The equation of this reaction is, we have the daughter nucleus here, parent nucleus X, transform into daughter nucleus with the release of this particle, which is the positron. A equal A prime, A equal A prime, because here 0, and Z equal Z prime plus 1, right? Example of this, phosphorus transform into silicon and positron. Look here, 14 plus 1, 15. So here we have 15. 30 plus 0, 30. Right? Okay. Now, or so far, we have identified the 4 particles or radiations: gamma, alpha, beta minus, and beta plus. Now let's go to the law of decay. Or the period of decay, half-life. What does this mean? You know, unstable nuclei are disintegrating, means transforming, into more stable one. Means if we have right now 20 unstable nuclei, tomorrow they will not be 20 unstable. Why? Because some number transform to more stable nuclei, right? So if you have 20 X nuclei, tomorrow they will be less than X. Now the question is that how long it takes for this number of nuclei to decay by half, means to remain 10 nuclei. Initially you have 20 X. I want to know the time for half to remain undecayed, means half of them decayed into nuclei Y. This is called the period or half-life, and we have to learn by heart this definition. So the half-life or period T of radioactive nuclide is the time taken for half, notice here, for half to decay. If half decayed, I mean half transformed, then how much remain, or how many nuclei remain? Half, right? So look at this curve. We have here the number of undecayed, not decayed, undecayed nuclei. At t equal to 0 means right now we have this initial number, which is 20, say. Now this number decreases with time, and this is logical because the nuclei are transforming to other nuclei. So this curve decreases, means the number decreases. The question is how much or how long it takes for this number to become half of its value. This time is called half-life or period. Okay? We're only responsible for its definition, not the mathematics. Also, scientists interested in something called rate of decay. Rate of decay means the number of nuclei that disintegrate per unit time. Disintegrate means transform or decay per unit time. Clear? So how many nuclei disintegrate per unit time means in 1 second, say. It is called what? Activity. Called activity, which is the rate of decay, symbol A. So activity is A. Okay? Let's make a direct application. Here we have an example. We are given the half-life of iodine is 8 days. It disintegrates into xenon in the ground state. So he said in the exercise, xenon, which is a daughter nucleus, created in the ground state, means no emission of gamma. Part A, write down the equation of the nuclear reaction and identify the emitted radiation or emitted particle. Okay? So here, part A, in this equation, write down the equation. Iodine, here is the iodine, which is the parent nucleus, transform or disintegrate into the daughter nucleus, which is xenon. Okay, Xe, sorry. Xenon plus a particle, plus what? Emitted radiation or particle. Right? This is the reaction. Now we want to identify this particle, means we want to know A and Z for this particle. If we apply Soddy's laws or conservation of mass number and atomic number, look here, 131 conservation of mass number equals 131 equal 131 here in the daughter plus A, right? Plus A implies A equal 0. You agree? Also, conservation of atomic number. 53 equals 54 here, right? Plus Z. This means Z equal -1, right? So this particle has A equal 0 and Z equal -1. In your opinion, what is this particle? This particle Z -1 means the charge is negative and the mass is 0. Surely it's what? Yes, as you said, it is electron. E -1, 0. So we have identified this particle. Now part B. In part B, he says 4 grams of iodine are implanted in the thyroid gland of a patient. Calculate the mass of iodine that remains after 32 days. Of course, we must use the rule of half-life. Okay? First of all, I have to know the number of half-life here. Here we have the half-life is given. Half-life is how many days? 8 days. 8 days. And the time, total time required is how much? Total time 32 days, right? So the total time, look here, that remains after 32 days. And the half-life is how much? 8 days. So in 32 days, how many periods or half-life exist? So if you do the calculation, you notice that number of half-life or number of period is 32 divided by 8, because total over 1, which is 4 period. Clear? So you need 4 period to know the mass. So if we say initially the mass means right now, the mass is 4 grams. Initially the mass is 4 grams. After half-life, after 1 period or half-life, how much remain? Now according to this definition, half of it remains, right? That's the definition. So remains 2 grams. Now 2 grams after half-life remains 1 gram, always by half. Now half-life 1 gram you have, and half-life after half-life 0.5 gram. Okay? Now how many half-life we have so far? 1, 2, 3. And after half-life we get 4 half-life, because how many half-life I need? 4. So 1, 2, 3, 4. I have here 0.5. Half of 0.5, 0.25 gram. So the mass that remains after 32 days, 0.25 gram. Okay, this is everything about radioactivity. Study it well. Take care. Bye bye.